Hello everyone. So in the first module we left out with some two more topics. So today we'll quickly learn that two more topics. Okay. So first one is operating system structure. Okay. So there are different type of operating system structure. The first one is simple structure. So whenever they're designing the OS in initial day, the structure of the OS was very simple. Means they don't have a well defined. Okay. They are not well defined system, or they can say they don't have well defined structures. Okay, so they're very small. Okay, it was very simple, and again it have a limited features. Okay, the limited system. Later they grow into advanced options by gradually increasing the implementation. For example, we can say MS DOS or Unix OS. Okay, so these are the example of the simple structure. Okay, so again in MS DOS it is different. Okay, MS DOS have like different levels of functionality. It makes different levels of functionality. It works based on that one. Okay, but whereas in the Unix it will have a user part and kernel part. Okay, so you can say that user part system programs and kernel programs separate like device drivers. All this one was coming up. Okay, so in the operating system structure. So second method is layered approach. Okay, so they come up with the second type of approach of the structure, that is layered approach. Okay, in the layer approach what happens, they'll have a different number of layers or number of levels. Okay, you can say different number of layers or a different number of levels we'll have. Okay, so each layers, okay, what it does, each layers have their own work to be done to communicate with the top layer and the bottom layer. Okay, so what we can say, they relay. Okay, they relies on the services provided by the next layers. Okay, it'll take the services provided by the next lower level layer. Okay, you can say like that. Okay, so for this one you can draw one small diagram just for understanding purpose. So this will be our hardware. So hardware will be in the level 0. Okay, so top of that again we'll have a different layers. Okay, so top of that again we'll have a different layer one. Okay, they can have any number of layers, and the topmost layer is user layer, that is user interface. So we can say this one as a layer n. Okay, in the middle it can have many layers. Okay, so this is the way they are designed as a layered approach. Okay, so layered approach has its own advantages as well as disadvantages. Okay, so then comes the third type. Okay, so third type of structure is microkernel. Okay, there's a name itself say it's a microkernel. That's a small kernel. So what is a microkernel? Means it'll remove that this kernel will from the main kernel, we'll remove off. Okay, whenever we remove all unnecessary and not essential. Okay, unnecessary or not essential. Okay, whichever the part is not essential component, if you have removed and made it a simpler way, so then we call them as a microkernel. Okay, so this is what happened, it will implement only the things whichever we wanted. Okay, in the system perspectives. Okay, and the user perspective. So both also, which it will check out whichever we wanted, so that it becomes more efficient compared to the normal kernel. Okay, yeah. So we'll draw one small diagram for this one also. So if we have a microkernel, so it interact with the hardware. Okay, and we have a different application like application programs, then file system, then device drivers. Okay, so they communicate with each other through the messages. Okay, so there's a microkernel. So what this kernel will do, it will take only the parts whichever they want. For example, IPC, inter process communication. Okay, and it want memory management. Okay, so that one will take memory and CPU scheduling. Okay, so it'll take only the parts whichever it wanted into the kernel and make the work more efficient and better way. So that is called as micro kernel. Okay, next comes last but not least structure, that is module wise. Okay, the fourth type is modules. Okay, so now the modern OS, okay, they'll have a modern OS. So whichever is based on the object oriented, okay, whichever consider the object oriented concepts. Okay, so it will become the core kernel. Okay, it becomes the core kernel, but have a different modules. Okay, modules means it's a divisions. Okay, each module will work for each different ways. For example, Linux, Mac OS, all this comes under this module. Okay, Mac OS, Linux, and Solaris all comes like a module based operating system. Okay, so these are the four type of operating system structure. Okay, so the last topic but not the least topic, that is virtual machine. Okay, this is our last topic of our syllabus, so that is the last one is virtual machines. Okay, so what is virtual machine means, whenever we want to abstract the hardware. Okay, we have a single computer, the single operating system. Okay, single computer means it will have one CPU, one memory, hard disk drivers, network interface card. We have all these options as a single computer. We have all this one. Okay, but we want to create a several environment. Okay, we want to create a several environment. Okay, so they create a illusion that our system have a different environment. Okay, it supposes to execute the programs in different environment. Okay, so it'll create a illusion. Okay, so that is called as virtual machine. Even though we have a single computer, we'll make an abstract that we have a different hardware and our different program is running in a different hardware. We'll create that illusion. That is nothing but it is called as virtual machines. Okay, usually there'll be a host OS, the main OS, that is called as host OS, that is main and it is only installed into the system. Okay, and other OS, other than the main OS, other OS are installed in the system called as guest OS. Okay, getting it? So we'll learn this one with a simple diagram. See the normal, a non-virtual machine, how it will be there, it will be a process. Okay, the processes is running here. Okay, we have a kernel. Okay, and we know the kernel will interact with the hardware. Okay, so this is the normal machine. Okay, that is non-virtual machine. Okay, but here in the virtual machine, VMware, how it works means we'll have a hardware. Okay, so top of that we have a virtual machine implementation. Okay, so without virtual memory implementation, we can't include the VMware. Okay, so here what happened? We have virtual machine 1. Okay, so again we have another division, that is virtual machine 2, another virtual machine 3. So now in this system we have a 3 virtual machine. So 3 different type of process will be running here. Getting it? And 3 block, we have 3 different process. So they believe they are interacting with the 3 different kernels, different environment. It'll allow the user us to feel that it's working in a different environment, but our main hardware and virtual means a single one. So that is called as virtual machine. Okay, so VM is nothing but the short form of virtual machine. So this is one virtual machine, this is one virtual machine, this is one virtual machine. So in this one, the 3 process believe they are working in a different environment with a different option priority, but the basic concept is the same hardware. Okay, only the we implemented VMware so that it can support different type of operating system on the main OS. Okay, we'll have a host OS, on that we'll have some guest OS. So on the top of the main ways, all these virtual ways will act as a separate independent ways and allows the process to work in a independent with a different environment. Okay, so this is our end of the first topic. This is the last topic but not least. Please do subscribe and like for more such videos, and we'll continue with the next module in the next class. Thank you for watching.